Okay, so some homework problems from 2.4. This is number 9. And I forgot to mention that, again, some of your numbers here might be a little bit different, but it should be the same idea. So the first question, number 9, is h of t is equal to t cubed over t to the 8 plus 7, and then the whole thing squared. And of course, find the derivative. So there's a couple ways of doing this. One way is to think of this as some function, I guess I'll call it g of t, squared, right? Where g of t is just what's in the parentheses, right? T cubed over t to the 8 plus 7. So taking the derivative then requires the chain rule. So it's 2 times g of t to the 1. I won't put a 1 there because it looks like a prime, right? And then by the chain rule, we multiply by the derivative of g. Okay, so this is just going to be 2 times g of t, t cubed over t to the 8 plus 7 to the 1. And then we have to multiply by the derivative of the same thing, t cubed over, oops, sorry, getting ahead of myself here, t to the 8 plus 7. All right, so that's the hard part here. This, of course, requires the quotient rule, right? And we did some of that in the previous section. So let's just use the quotient rule here. So I'll keep the 2, in fact, I'll put the 2 in the numerator, 2t cubed over, I did it again, t to the 8 plus 7. So that's just the first factor here. And now we multiply by the derivative of t cubed over t to the 8 plus 7. So t to the 8 plus 7 squared is in the denominator. And then we have low d high minus high d low. So denominator times the derivative of the numerator is 3t squared minus the numerator, t cubed, times the derivative of the denominator is 8t to the 7 plus 0, right? So the rest is just simplifying. So 2t cubed over, okay, let's one step at a time. So keep that, and then let's just simplify this. So keep the denominator, and let's just multiply out the numerator. 3t squared times t to the 8 is 3t to the 10 plus 21t squared minus 8t to the 10. So 3t to the 10 minus 8t to the 10 is negative 5t to the 10. So I desperately wanted to multiply this out already, but I'll do that on the next step. So, yep, we're going to get negative 5t to the 10 plus 21t squared. Okay, so now just distribute in the numerator. You're going to get negative 10 t to the 13th power plus 2 times 21, so 42 t to the 5th power. And then in the denominator, we have t to the 8 plus 7 to the 1 times the same thing squared. So 1 plus 2 is 3, so the exponent there is 3. And I think we got it. I think that's probably good enough. You could make the case to factor out, let's see, a negative 2t to the 5th in the numerator, leaving you with, let's see, 5t to the 8 minus 21, just minus 21, right? All over the same denominator, t to the 8 plus 7 to the 3. All right. Again, I think either way is fine here. All right, number 15. This is also pretty difficult one. It's to be fair, it's also a little bit contrived. You're not going to see a function like this very often, right? So y is cosine of the square root of sine of cotangent of pi x. Find the derivative, right? So before we take the derivative, I think it might be beneficial to write this as the y equals the cosine of sine of cotangent of pi x. And then, right, because it's the square root, it's raised to the power 1/2. We're taking the cosine of all that. Okay, so this is just a repeated application of the chain rule. So in order to take the derivative, dy over dx, and as long as it's clear that the independent variable here is x, you can also write y prime or y prime of x to be a little more specific. But if it's clear that, that the independent variable is x, we'll just use y prime. All right, so the derivative of cosine is negative sine. So we're just taking negative sine of all of this. Cotangent of pi x. And then all of this to the power 1/2. Right, square root of the whole thing. All right. Now we're not done because now we need to take the derivative of that whole thing. So I'm just going to copy this down. It's the derivative of sine of cotangent of pi x to the power 1/2. Okay, so that's a power rule, right? It's just a function to the power 1/2. So, and I hate copying this down all the time, but that's what we have to do here. Yep. Right, so now we're just taking the derivative of this thing to the 1/2. So we're going to multiply by 1/2 times this whole thing, sine of cotangent of pi x, right, to the power negative 1/2. And then by the chain rule again, we need to multiply by the derivative of sine of cotangent of pi x. I think I have just enough space to fit that in here. Right? Yeah, this is a little sloppy here. This is cotangent. All right, so I think let's bring the 1/2 in front here. So I'll write this as negative 1/2 times the sine of, I'll leave it as to the power 1/2 here, right? Sine of cotangent of pi x to the power 1/2 times the same thing, right? Sine of cotangent of pi x to the negative 1/2. Can't forget that, right? All right, and now we just need to multiply by the derivative of sine, which is cosine of cotangent of pi x. By the chain rule, we multiply by the derivative of cotangent of pi x. Okay, so this is quite a handful here. I'm just going to copy it down. Okay, so I just cut and paste all this, and now we just take the derivative of cotangent of pi x. So the derivative of cotangent is negative cosecant squared of pi x. But we're still not done because now we have to take the derivative of pi x, which of course is just pi. And we'll just bring the pi in front, I think. So let's see, negative pi over 2 times the sine. And at this point, I'm going to turn this back into a square root of sine of cotangent of pi x. And then, well, since this is to the negative 1/2, I guess that'll be in the denominator. So divided by the square root of sine of cotangent of pi x. And then back in the numerator, we have cosine of cotangent of pi x times a negative. So I think we have two negatives here, right? That makes it a positive. It's a negative times a negative is positive, right? So then we have cosecant squared of pi x And I brought the derivative of pi x was just pi, and I brought that in front. Okay, so I think that's it. There's probably a better way to write this. For one thing, we can just bring the 2 downstairs. So how about if I write pi cosecant squared of pi x times the cosine of cotangent of pi x times the sine of the square root of sine of cotangent of pi x, all divided by 2 times the square root of sine of cotangent of pi x. Yeah, like I say, a bit contrived, but it's a function of a function of a function of a function of a function. I think so. We had to use the chain rule 4 times here. Let's see, 1, 2, 3, 4. Yeah, 4 times we had to use the chain rule. Right? Should we count them? Right? So the first one was here, taking the derivative of this. So that's the first chain rule. And then here's the second chain rule. And then here's the third chain rule. And then the fourth one, the derivative of pi x. Again, that was the easy one. It's just pi. There's the pi in front. So yeah, not a pleasant problem, but that's about as bad as it gets. So, all right, last one. This is number 18. And this is one where they really break it down into a whole lot of steps, maybe too many steps. But I'll go through it, step by step, as if this were on a test, right? So the function they give us is 4 cosine x plus 2 sine 2x. And they want us to determine the points at which the tangent line is horizontal. So what does that mean, right? If you have a graph and you have a point at which the tangent line is horizontal, well, that means the tangent line has slope 0. So in other words, they want the slope, or the derivative, to be equal to 0. Right? So there's a couple steps here. First, we have to take the derivative of this, and then set it equal to 0, right, and solve for x. Okay, so first step is to just find the derivative. And in this form, the derivative of 4 cosine x is negative 4 sine x. And then the derivative of 2 sine 2x, so there's a chain rule here, right? So 2, and then the derivative of sine is cosine, so cosine of 2x. And then the derivative of 2x is 2, right? And this 2 times this 2 is 4. So this is just negative 4 sine x plus 4 cosine of 2x. Okay. And we could factor out a negative 4 here and write this as negative 4 times sine of x minus the cosine of 2x, right? And so that's the derivative. Now we have to set this equal to 0 and solve, right? So we have to solve this for x. Right? And here's where it gets a little tricky, because in this form it's very difficult. First of all, we could divide by negative 4. That doesn't matter. Right? So at this point we have to solve the equation sine x minus the cosine of 2x equals 0. Okay, so again, this is not an easy equation to solve in this form. However, cosine of 2x should remind you of something. This is the double angle formula. Cosine, let's write that again. Cosine of 2x, we could write this as cosine squared x minus sine squared x, or 2 times the cosine squared x minus 1, or we could write it as 1 minus 2 times the sine squared of x. Now, which of these three should we use? Well, notice that in the equation here, the only other term we have is the sine x. So if we can write everything in terms of sine, then I would use the bottom one here, 1 minus 2 sine squared, because all the others still have a cosine in it. So we can change everything to sine here by writing this as sine x minus 1 minus 2 sine squared x equals 0, right? All right. And to simplify this, we're going to get 2 sine squared x, right? Because it's a negative times a negative is positive, plus sine x, and then just the negative 1 here. Okay. All right, so at this point, this should look like a quadratic equation. In fact, it really is. You can think of this as, let's say, 2u squared plus u minus 1 equals 0, where u is just sine of x, right? So we can either use the quadratic formula, or I think we can factor this out. You should be pros at factoring by now. So let's see, this is going to be a 1 and a 1. Where does the negative go? Does it go here? So we have negative 2 plus 1 would be negative 1, but this is a positive. So I got it backwards. It's going to be negative positive, right? So 2u minus 1 equals 0. So u could be 1/2. Or u plus 1 equals 0 gives us u equals negative 1. Okay, so those are the solutions to this equation. Sorry, this equation here. But that wasn't the question. The question was to solve for x. So remember, u was just sine x. So sine of x is equal to 1/2, or sine of x is equal to negative 1. So how do we solve those? Just draw your unit circle. Everyone remembers the unit circle, I hope. So 1/2 is, right, remember, sine is the y-coordinate. Y is sine x, so y is 1/2. So that's about this angle here, or this angle here. So this should be pi over 6, or 5 pi over 6. So this equation on the left, sine x equals 1/2, has two solutions, pi over 6 and 5 pi over 6. Well, not quite, right? So this equation has infinitely many solutions, but I think I forgot to add one important thing. Determine the points on the interval from 0 to 2 pi. So from 0 to 2 pi, in other words, just going once around the circle, there's only two solutions, right? And then where's sine of x negative 1? That's at the south pole here, right? So that's negative pi over 2. However, if you're going from 0 to 2 pi, you can't go backwards, right? You got to go counterclockwise. So this is coterminal with 3 pi over 2. So this equation here has only one solution, at least from 0 to 2 pi, and that's 3 pi over 2. So there's three solutions altogether, right? Pi over 6, 5 pi over 6, and 3 pi over 2. Right? And we're still not quite done because the question is to find the points at which the tangent line is horizontal. We only found the x values. Right? We're looking for x and y. So what is y when x is pi over 6, 5 pi over 6, and 3 pi over 2? Right? So to get the y values, we have to go back to the original function. So let me remind you what the original function was. It was 4 cosine x plus 2 sine 2x. And we could have simplified this, or use the double angle formula here, but not necessary, right? So let's start with pi over 6. When you plug that into the function, you get 4 cosine of pi over 6 plus 2 times the sine of 2 pi over 6. But 2 pi over 6 is also just pi over 3. Okay, so cosine of pi over 6 is square root of 3 over 2 plus 2 times sine of pi over 3 is also square root of 3 over 2. So that's 6 square root of 3 over 2, or or just 3 square root of 3? So that's the y-coordinate when x is pi over 6. Okay, so for 5 pi over 6, we get 4 cosine of 5 pi over 6 plus 2 sine of, well, 2 times 5 pi over 6 is 5 pi over 3. Cosine of 5 pi over 6 is negative square root of 3 over 2. And the sine of 5 pi over 3, I think we're in quadrant 4, where sine is negative. So, yep, this will also be negative. Well, okay, let's keep the plus 2. Sine of 5 pi over 3 is negative square root of 3 over 2. I'm trying to think, is that right? 4 pi over 3, 5, yeah. Right, so this will just be negative 6 square root of 3 over 2, or negative 3 square root of 3. And I think you have the right idea here. Now just plug in the 3 pi over 2. So 4 times the cosine of 3 pi over 2 plus 2 times the sine of 3 pi. Right, so cosine of 3 pi over 2, cosine is the x-coordinate, so that's 0, 4 times 0. And sine of 3 pi is also 0. So 0 plus 0 is 0. So the y-coordinate here is 0. So these are the 3 points at which the graph will have a horizontal tangent line. Remember, the tangent line is horizontal, means the derivative is 0 there. So 3 points on the graph where the tangent line is horizontal. And to be clear, 3 points only between 0 and 2 pi. Right? In other words, only on one complete period of the graph here. All right. Again, so that was a tricky one. I hope you got all that. And it's just breaking it down into little steps. So that should be good enough. All right, so that's 2.4. Okay, so 23. And I know this is very tiny, but I'm going by what was on WebAssign. So I'll read it to you. It says, let R of x equal f of g of x, and s of x equals g of f of x, where f and g are shown in the figure. So this is the graph here on the left. Find r prime of 1 and s prime of 4. Okay, so yeah, we're looking for, we want to find, right, this is part A and part B. Okay, so r of x is f of g of x, and just to remind you, because this book prefers to write it this way, and I do too, but some books will write it as f circle g of x. So whenever you see this notation here, you should immediately write it as f of g of x, right? Likewise, g of f of x is sometimes written as g with a little circle of f of x. But luckily, our book doesn't use that. Okay, so let's take this step by step here, right? What's r prime of 1? So part A, r prime of 1 equals what? Well, before we can plug in 1, we need to know what r prime of x is, except we don't have a formula for f of x or g of x. So we're not going to be able to do it that way. Instead, we're going to think of this as the derivative of r of x, and just we plug in x equals 1, right? So we're going to need the chain rule here because r is defined as f of g, right? So the derivative of r of x is the derivative of f of g of x. And, right, that's the chain rule. So I hope you're not thinking product rule, right? This is not the product rule here. And just to remind you, if I wanted the product rule, I would write this as f of x times g of x. Do you see the difference, right? This is not f times g of x. It's f of g of x, right? Which is not f of x times g of x. So yeah, don't get confused with the product rule here. This is a function of a function, so this requires the chain rule. Okay, good. And the chain rule just says that this is the derivative of f of g of x times the derivative of g times g prime of x, right? Fine. Okay. Okay, so now we can plug in 1, right? So I'll just rewrite it. R prime of 1 is just going to be f prime of g of 1 times g prime of 1. And let's just write that down here. Well, I think this is probably good. Right? So what's this g prime, what's g of 1? So we have to look on the graph because we don't have a formula, right? So here's x equals 1. And what is g of 1? It's the y-coordinate right here. And it looks like it's the point 1, 4, right? So g of 1 is equal to 4. Right? So this is going to be f prime of 4 times g prime of 1. Okay? So let's start with f prime of 4. What's f prime of 4? F prime of 4. So if we look on the graph, here's x equals 4. Here's f of 4, which is approximately, I don't know, somewhere between 2 and 3. I don't know, we'll call it 2.5 maybe? It looks pretty close to 2.5. That's my lousy picture here. So, yes. But we're not looking for f of 4, we're looking for the derivative of f at 4. So the derivative, right, is going to be the slope at this point. So what is the slope at that point? Well, this looks like a straight line, so we just need the slope of the line. So f prime of 4 is just the slope of the line segment. And notice the line segment passes through 6, 5 and 2, 0. So the line passing through 2, 0 and 6, 5. So how do you find the slope? That's the usual rise over run, right? y2 minus y1 over x2 minus x1. So x1 is 2, y1 is 0, x2 is 6, y2 is 5. So just plug in all the numbers. This is going to be 5 minus 0 over 6 minus 2. So that's 5 over 4. Okay, so that's f prime of 4, right? 5 over 4. Or if you prefer, 1.25. I prefer the 5 over 4, right? Okay, so the first factor here is 5 over 4. Now, what's g prime of 1? So go back to 1. That's this thing in red here. And then when we go up, we know y is 4, but we want, right, g prime means the derivative. So what's the slope of this line? And I hope your answer is 0 because it is a horizontal line, right? It's a horizontal line segment, right? At least from x equals 0 to x equals 2, right? That this is a horizontal line. So the slope is 0, right? So in other words, g prime of 1 is just 0. Okay, so this is 5 over 4 times 0. Anything times 0 is 0. So the answer here is 0. Right? So r prime of 1 is just 0. Okay. All right, so now I made a complete mess out of this. But the next part B is to look for s prime of 4, or the derivative of s at 4. So what is, this is part B here, s prime of 4. Now remember, s is g of f of x. It's right here at the top, g of f of x. So the derivative is going to be g prime of f of 4, that's a 4, times f prime of 4. Okay. So first, what is this f of 4? What is the y-coordinate when x is 4? So when x is 4, we go up to the graph of f, and we said earlier it's about 2.5, right? 2.5, or we'll just say 5 over 2. Right. Times f prime of 4. Okay, right. And again, if you like g prime of 2.5, that's fine too. All right, what's g prime of 2.5? So to answer that, again, there's no formula here for g. We have to look on the graph. Okay, so 2.5, and I'm running out of colors here. Let me use, how about purple? So 2.5 is halfway between 2 and 3. And we're looking for the derivative of g at that point. So we have to go all the way up to this point here and look for the slope at that point. We're not looking for the y value, we're looking for the slope. So what's the slope of this, this line segment here? Well, we can use, y2 minus y1 again, or just note that it's rise over run. We go up 1, right 2, up 1, right 2. So it's just 1 over 2. Okay, so g prime of 2.5 is 1/2. Now, what's f prime of 4? So what's the derivative of f at x equals 4? It's the slope of this line segment here. But we already answered that. We did that in part A, even though it wasn't necessary. Now it is, right? This is the answer to f prime of 4, right here, right? It was equal to 5 over 4. So f prime of 4 is just 5 over 4. We can go through this whole argument again here, but it's the same answer, 5 over 4. All right, what's 1/2 times 5 over 4? Should be 5 over 8. Or if you prefer, 0.625. Personally, I prefer 5 over 8. So s prime of 4 is 5 over 8. And that's the answer for part B. Okay, so yeah, this is also a bit of a tricky question simply because they don't give us the formula for f or g. They don't tell us what f of x is. They don't tell us what g of x is. In terms of the formula, they just give us the graphs. But that's good enough. You should know how to read graphs, and in particular, you should know how to find the slope of a line on a given graph, right? Okay, so yes, this is an exercise in reading graphs. And also the chain rule, of course. If you don't know the chain rule, you're not going to be able to answer the question either. So, all right. So I hope this helps.